Hello, Sabrina. Ethan, has your school finished the syllabus? You at macromolecules.
Yeah, something.
Sabrina, your side too?
About practicals now.
Practical. Oh, okay. Then, do you have any particular question?
Yeah, all the marks.
That one. Okay. Maybe let me finish this chapter first. Do you have a sample paper or something?
Submitted all.
Oh, okay. Okay, let's finish this off on air quality. I think we stop here. Let's continue for number 3. Ethan, what is meant by desulfurization? Yep, that's all. Removal of SO2 from flue gas. I have used this word like last week or the week before. Try to take note of it. It can come out in your exam. It means waste gas. Next, chemistry involved in desulfurization. Sabrina, how do you answer that?
It's not to
Okay. What's the other possible reactants instead of using calcium carbonate? Yep, Ethan? Yep. That is the other possible reactant or absorbent for SO2. Now, of course, this question asks to explain, so do write words and don't. I mean, you can write your equations in, but make sure you write words as well. And you're supposed to know the full equations for this two. Okay. Ethan, what do I get here? Right, be careful the formula, SO3, not SO4. Ethan, this one? Yep. Right, you're supposed to know both of them. Sabrina, importance of desulfurization? Okay. Now, depending on the marks, you may also want to mention the consequences of SO2. Ethan?
Less formation of seaweed.
So, yeah, I think that captures the elements for this answer. All right, desulfurization, basically you want to reduce SO2 in the air, and therefore you reduce incidences of acid rain. Yep, those would be the key points. Number 4 is very standard. Expect it to come up in the exam. Have you done all your questions?
Yeah.
What is X? Number 4. Okay. Yeah, of course, you can also mention rhodium. Ethan, purpose of X?
To act as a catalyst to turn gases from ethylene into cleaner.
Okay, good. Right, it catalyzes redox reactions to turn air pollutants or engine pollutants, if you want, into less harmful gases. Now look at part B. B is a bit tricky. Try not to be careless. Sabrina, B part 1. Okay. One more? I mean, they asked for 3, but what's the other one? Don't forget, the converter also handles unburned hydrocarbons. Oh, just a very, very small comment. Small but important. They asked to name. So yeah, guys, write out the full names rather than the formulas. Sabrina, part 2, not affected by X. Nitrogen, carbon dioxide, and water vapor. Okay. Okay, good. You can, Dylan.
Yeah.
Okay, part C. 3 gases in Z which are produced from chemical reactions as Y passes through the catalytic converter. Ethan? Okay, guys, by now you should be very, very familiar with the answers of these questions. Okay, these are the products of the redox reactions. What equations for 2 reactions that take place in the catalytic converter? D part 1. Dylan?
Carbon dioxide get reduced to nitrogen gas.
Okay.
And carbon monoxide oxidizes to carbon dioxide.
Well, of course, as the name implies, you're supposed to spell them out. Word equations. Nitrogen dioxide becomes nitrogen. Carbon monoxide becomes carbon dioxide. Okay, so yeah, of course, no need to balance. Type of reactions that occur. This one, I mentioned the answer just now. So your answer is redox. Why lead-free fuels must be used? Sabrina? Yep. All right, remember, lead is a poison for the catalyst. Right. So, and of course, it can reducing the function of the catalyst. Now, of course, if you keep on using lead, eventually the whole catalyst cannot work. Look at section C. This is a very typical kind of free response question expected. And maybe even more than this. The data here is not that much, but if you look through past year papers, some of the data is a lot more than this. Okay, look at part A. Why are nitrogen oxides and carbon monoxide found in car emissions? Yep, Ethan? Not entirely true. CO is from incomplete combustion. make sure you have the words incomplete combustion in your answer. Okay, and of course that happens in the car engine. But nitrogen oxides is different. Yep, Ethan, take note. Yep, Dylan, where do nitrogen oxides come from? I mean, in the car engine too, but how do they form?
The temperature is low.
The temperature is?
No.
Oh no. The T is high temperature.
Oh.
High temperature in engine as well. It must be really be higher. You're talking about 1000 degrees Celsius. Can combine N2 and O2. To form nitrogen oxides. You need that high temperature. Otherwise, you have nitrogen oxides all over, even in our room right now. E is very, it's not easy, and but I expect it to be a common question if it comes up. Why concentration of air pollutants is different between idling and accelerating? Oh, for starters, do you know what's idling? That means your engine is running, but your car is not moving. Sabrina, how do you answer this?
Since it has a lower temperature, lesser amount of gases in the fuel are combusted. Hence, more air pollutants are produced since more incomplete combustion takes place.
Okay, for you probably can get some marks. Because this question expect you to separate the air pollutants. You cannot lump the air pollutants all together. That is the difficult part. So try to think that way. Not just for this kind of question, but for other questions, you analyze carefully. You may not want to lump everything together in a single explanation. Okay, but let's look at the data first. Look at, by the way, you better recognize this is referring to hydrocarbons. CXHY, it decreases from idling to accelerating. NOx increases. CO decreases. So you may want to work along those lines. Which air pollutants decrease in concentration, which increases in concentration. All right. Oh, of course, guys, don't waste the other data too. Notice idling, less air. More air. More air means what? Yes, more oxygen, and of course, it will tend to have more complete combustion. Now, likewise, look at the temperature. Temperature is an important factor actually in this question. Hopefully you notice temperature here is higher during acceleration or accelerating. Okay, so let's structure our question accelerating. Okay, basically temperature is higher. So this is conducive to produce to producing more NOx. You probably don't know about this fact, so yeah, this is the difficult part. You have to figure that out. You have to link temperature to formation of nitrogen oxides. Okay, on the other hand, idling. Okay, for idling, you have less air. I'll follow Dylan's logic. That means you have less oxygen. And that means less complete combustion. And therefore, more CO and unburned hydrocarbons. So be a bit discerning. You probably cannot explain everything with a single explanation. If necessary, split up your substances. Okay, part C, Ethan? Yep. Okay, I think this one is quite straightforward. All of you should be able to do it. Catalytic converter. Make sure, well, you don't know how many marks this is, so to be sure, you have to explain what happens to hydrocarbons, what happened to NOx, and what happens to CO. You should be able to get the marks for this question. Okay, all this should be in your head already. Number 2 is an unusual question. May or may not come up again. Okay, A. Sabrina, what is an air pollutant? Oh, unwanted and harmful. Okay, I think that's fine. All right. Let me use her words. Unwanted and harmful substance introduced into air. Greenhouse effect, Sabrina? What's the last part? Sorry, the form. Oh, okay. Okay, greenhouse effect, basically greenhouse gases in atmosphere trap solar radiation. And prevent it from escaping. I think those are your words. Wow. Keeping the earth warm. Yep, those were the key points. Greenhouse gases, trap solar radiation, keep the earth warm. How about part B? 1860 to 1990, increase in CO2. Explain how this conclusion can be made. Ethan?
Hence, it be concluded that the CO2 emission is all of the atmosphere.
Okay, I think that's about it. But again, you don't know how many marks this is. Do you need to add in figures inside? That one is subjective. All right, for chemistry, maybe not so much. Yeah, unless you're taking bio, then bio are very particular. Okay, but for chemistry, no. So basically, graph on shows an increase in CO2 emissions. From 1860 to 1990. Here, graph 2 also shows a corresponding increase in temperature. Right, therefore, we conclude that increase in CO2 leads to increase in atmospheric temperature. I mean, if you want to be systematic about it, then you write it out sentence by sentence. Graph 1, what does it show? Graph 2, what does it show? And what's your conclusion? Yeah. Dylan, do you answer part 2? B part 2?
Good. The graphs are not increasing steadily and decreases at times.
Which graph?
I think both graphs.
Both graphs. I think that is fine. But it's not strong enough, so you are not likely to get the full marks because your answer is a bit unclear, a bit superficial. So one way you can answer this, it's going to be a bit more specific. I think if you look carefully, especially here, this particular spot is the, I think, largest decrease in temperature, and it's about, if you want, you can try to gauge the, I don't know, this is about what, 1900s, right? 1900 to what? I don't know, 1910 maybe, or you just give a rough estimate. So basically, in graph 2, again, let's be very systematic. Here you're talking about graph 2. There was a large decrease in I can, instead of giving the years, I will just put it around 1900s. However, like I say, be specific, talk about graph 1, graph 2. Graph 1, the CO2 continued to rise. Around 1900. Therefore, now, I mean, you may think that it's a bit redundant, but still it's always, if you have the time, unless you're short of time, it's good to be very clear about your statements. A rise in CO2 does not necessarily cause a rise in temperature. Okay, so I know this question is a bit unusual, but just bear this in mind in case such a question comes up. How do you challenge the conclusion? This is, I think, the most logical answer that you can provide. However, look at part 3. If this kind of question comes up, you will expect part 3 to come out as well. Sabrina, how do you answer part 3? All right, good. At least you caught that point. Guys, remember this if you can. Okay, other greenhouse gases. They were not recorded. Okay, even though they could have affected the atmospheric temperature. Okay, that would be the obvious one. Guys, again, do remember the CO2 is not the only greenhouse gas. Make sure you know there are others. Which is the other common one besides CO2? The second most common. Yeah, guys, take note. CH4, methane, is a greenhouse gas as well. And having said that, maybe I draw out the list for you. But of course, if you think you can't remember so much, then so be it. It's okay. CO2, you must know. And I strongly suggest you know about methane as well, CH4. But in case the question comes up a bit weird this year, ozone is a greenhouse gas still? CFCs are greenhouse gases? Ethan, what are CFCs?
Fluorocarbon.
Fluorocarbon, only 3 elements. This one is a bit obscure, but it did come up once in a while. N2O. Take note, this is not NO. This is not NO2. It's N2O. It's not a typo. Okay, there's N2O, even though it doesn't come up often. Does anyone have any other answers for part 3? No? I'll just give you one more. If you want, you can remember that. If not, then never mind. Do you realize that obviously the temperature on Earth and the atmosphere depends on solar radiation, and solar radiation is not constant, right? So the other factor is solar radiation, or to be more exact, intensity of solar radiation is not accounted for. And it fluctuates, fluctuates with time. Maybe 100 or 100 years back, the solar radiation was a lot weaker compared to now. All right, that covers this chapter. Any questions from anyone? All fine. Dylan?
Yeah.
Fine. I think there's one question I thought I want you all to try out.
Equals 7 and 15 equals to 6. So now you have a problem. You want to move this to the other side. Okay.
This
So
is
you move this to the other side.
Sabrina, have you tried this question? No. Okay, it's about the catalytic converter, which they like to ask. Maybe not this one. This one is a lot more difficult, and I'm not really expecting this to come up. Okay, but I'll just let you try this one. Catalytic converter. Okay, let me print it out for you.
I can make -3, -15. -2 is equal to 6. -1, or -1 times 1 gives you. There's an invisible one here. So let's see this. -1 times 1 gives you -1. Then -1 times -x gives you plus x. So next step, you have to move all the x to the left hand side. How do you do it? And some different. This x over here. So to move this over here, yes, correct. So 5x minus x minus 15 minus 2 gives you 6 minus 1 plus x. Okay, 5x minus x is 4x. Okay, then you solve here. Oh, it's with -15 minus 2. It's 17. Equals to 6 minus 1 is 5. Plus 1 minus 1 is 0. Okay. Now the problem here is you must move -7 to the other side. How do you move -7 to the other side? -7 is the left. Plus 17. 4x solution plus 5 plus 17. Use 4x. 5 plus 17 gives me. Okay, then to find x, you get 22 divided by 4. Your x is Wow. Very well. I'm going to get very confident.
Yep. Sulfur. Yeah, 32.
32. The amount. Oh,
I can't hide this shit if you have to do. They'll get used to it. How do you need? Yes. Later.
Six minus EX. Then we got minus 5 times root of minus 10. Minus 5 times quality 3. Which is root 5 times 3. Negative 15 x. Five negative 5x. Negative 21, negative 3 times negative 2, which is your quality 6x. Okay. Okay, the next step, you group all your x terms together, so all your negative 3x, x, x, so negative 3x minus 15x To move 5x over what we do? Like 5x. 5x plus 5x. And move your 6 over your minus 6x. So since you move over your negative 5 will disappear, right? And plus will disappear, so you get minus 21. So then you solve your x term here. Negative 3 x minus negative 2x plus 5 minus 6. You can take the you can take a later. You get it? The much easier to do I'll take negative 9. Or oh, yes, you move this over the other side, so you have 4. Negative, equals negative 16 plus 4 leaves you negative 12. Okay, so at this side, this has a negative on this side and this side. They both cancel out. So the negative side will be negative. Plus is negative. So you get 19 x is still 12. To find x, you take 12 divided by 19. This will do this night. Remove the give one times give one times increase the root minus 5. If one times of is 6x is you already 6. Okay. After that, remove like 1. If the x term is on your right hand side, then your number on the number. So first say negative 3 for x plus 15. Now, right? Then we minus something like 6. You minus of the number that 5x minus 6. I don't know if you ever very good right? Besides. There's like there's a big this is a big project. This is a smaller project. So when we see a big project where I at least rectangular living one, they always solve the type one. So it's all flip floppers. Before I move on to the big project. This one we get.
Dylan, done?
think so.
Energy.
Okay, show you the answer.
Yeah.
You get that?
Yeah.
Oh, okay, that's good. Sabrina, done? Still doing? Done? Done. Ethan, do you manage to get this answer?
Yeah.
Oh, okay, that is very good. Okay, come this question again. Long story here. Air fuel ratio, lean burn engine, higher ratio of air to fuel. How will a lean burn engine affect around CO and NO compared to a normal car engine? Explain. Yep, Sabrina, how do you answer this?
Just keep as small as those companion this one top.
And just the one otherwise.
So you say that your CO will decrease. How about NO? Decrease. Oh, okay. Why again, CO? Why does CO decrease? Dylan, how do you answer this? Do you have the same conclusion?
CO will increase.
CO increase. Oh, okay.
And it produces more and
More NO.
yeah.
So both CO and NO increase. But do you explain?
The lean burn engine produce more carbon dioxide, more carbon monoxide. There's a higher air to fuel ratio, meant there is more air and more oxygen for lesser incomplete combustion taking place for more CO. A lean burn engine produces more NO as it has a lower running temperature. Thus, it is not enough to completely combust the NO2 as it cannot reach a high enough temperature.
Okay. Okay, guys. Actually, this is a very ambiguous question. It's Okay, the thing is this, even though I didn't particularly mention it, but you may want to write down in case it comes up this year. The thing is, I want you guys to be very clear. Obviously, the car has an engine. One, okay, so we are talking about car engine. Then it is obviously your fuel air goes in. And then from the engine, it goes to your catalytic converter, which is under the body of the car. If you look under the body, you can see a big box at the bottom. Then the thing is this, whatever happens here may be different from whatever happens there. I mean, normally questions are not so specific, but sometimes it can be. So I want you to be very clear. Are you talking about the engine or the catalytic converter? All right, that is the tricky part. So first, let's go to the engine. So I have lots of air, meaning I have O2. Lots of O2. And therefore, you can safely say that there is more complete combustion, or if you want less incomplete combustion, try not to be confused yourself. Okay, more complete combustion. So that means what? You're likely to find less CO. Okay, can Dylan take note? You have more oxygen, more air, more oxygen, more complete combustion, so less CO in the engine. But on the other hand, Dylan, you're correct. You did mention about the temperature. So you have a lower temperature. Lower temperature means that you are going to have less NO. Because, again, I was talking about this earlier, N2 and O2 cannot combine well to form your NO. But on the other hand, do you want to consider the catalytic converter too? Well, the question is not clear about that. So to me, if you talk about this, actually you should get your marks as well. All right, the question is not clear. Are you talking about the engine or the converter or both? Now, let's go to the catalytic converter. Well, obviously, if you have lots of O2, it's going to go into the CC2. So therefore, you will tend to have high O2. And what happens to the redox reactions? There will be better oxidation. Don't use the word combustion, please. Combustion doesn't take place in a catalytic converter. It's better oxidation of CO to CO2. Okay, and therefore, your CO decreases as well. But what else? Now, since you have high O2, it means, this one is a bit tough. This one is maybe a new concept to you. It means the environment is more lean towards oxidation. And therefore, you have a poorer reduction of NO to N2. And therefore, you will tend to have more NO remaining. I'm not sure how your this year exam question is going to be, whether it's going to be this specific, but at least try to understand that there's a difference between the engine conditions and the catalytic converter conditions. Right, questions, anyone? Hopefully you're clearer now. Sabrina, okay. Good, fine. Okay, let's look at the next one. Overall equation. Right, guys, hopefully you can get a clue here. You notice O with square brackets, I think you've seen it before. It means the oxygen comes from a reactant, and in this case, your oxidizing agent. Now, my suggestion is this is common. Here I have 2 on the right-hand side. Here I have 1 on the left-hand side. So the logical thing to do is I have 2 there, I have a 2 here, I have 2 here. Okay, basically to balance that oxygen. All right, so once you have that, take this as equation 1, take this as equation 2, and you simply add equations 1 and 2 together. That will give you your overall. But of course, you can do it intuitively without going through all these logical steps. So that would be your answer. Okay, do you manage to get it? I hope so. The overall equation. But anyway, this comes up quite often. You may want to highlight this particular equation. So make sure you can write it out. Okay. Now you have some data. Any questions about understanding this graph? Can understand? All right, look at the first part. Increase amounts of air affect the removal of CO and NO. Okay, I think you guys, I more or less given you the answers earlier already about the catalytic converter. Okay, this I have make this answer sometime back, but I'll highlight the important points, make sure you have them. Right, amount of, oh, by the way, you still have to refer to the graph. What happens as you have more air? Okay, amount of CO removed increases. So that's what I wrote here. Okay, as air increases, based on the graph, CO removed increases to a maximum. If you can remember, write this down as well. It rises to a maximum and remains there. It doesn't keep on rising. It rises to a maximum. Explanation. CO is oxidized to CO2. So the more air there is, the more O2 is available for oxidation. Okay, so if you notice, the first sentence is about observation from the graph. And my second sentence is the explanation. Or the next two sentences is the explanation. I mean, if you notice, I try to be as systematic as possible in answering these questions. Okay, make sure you answer the first part. What do you observe from the graph? More air, more CO is removed. Up to a limit. Okay, likewise, you also have to talk about NO again. Observation from the graph. Okay, as air increases, the amount of NO removed decreases. But only after a certain amount of air is exceeded. And that is my observation. And I try to explain it. Make sure you have the words reducing or reduction somewhere in the answer. Okay, so the more air there is, oxidation is more likely to take place compared to reduction. All right, so this is about catalytic converter, but as I said earlier, sometimes be a bit discerning also. Is the question about the engine or the catalytic converter, or both? This is not an easy question, especially the one about explanation for NO. So you may want to highlight that it's not exactly talked about much. As you have more air, the catalytic converter adopts a more oxidizing environment compared to reduction. Now look at part 2. Apart from reacting with each other, CO and NO react with other substances as well. Hopefully, most of you can get this. Now, I think as earlier shown by this overall reaction, CO and NO react with each other. Okay, this was the equation given earlier, or you should have written this earlier. Right, for this, obviously you look at the graph. How does the graph show that this statement is true? Again, if I'm to be super systematic, this is what I will write. Okay, let's start from here. Now, as the amount of CO removed changes, you see it's moving out. But look at NO. The amount of NO is removed is still the same for this portion here. So therefore, you must conclude that NO has reacted with something else rather than CO. Notice CO is changing. But NO is constant. NO remove is constant. So it must have reacted with something else. Or you can talk about this part. As NO decreases, the amount of NO removed decreases. The amount of CO removed is still the same. So CO must have reacted with something else as well. Okay, so you can use both if you want to be comprehensive. I know it's a bit overkill for 1 mark, but then again, that is a comprehensive answer. Okay, but think about this way of reading a graph. Even though this exact question may not come up again, but you may have similar graph questions. Questions, anyone? No? Sabrina, okay. Right, just look at the last one, which involves calculation. Come, Sabrina, raw material. Yeah, limestone. I think, oh, you should get it. I'm not going to write it out. Part B, Dylan, why is it necessary to remove SO2?
Moving SO2 from the atmosphere, it reduces acid rain that could corrode limestone buildings or kill marine life.
Okay. Guys, it's a 2-mark question, so I suggest you write, obviously you have to write acid rain, but I encourage you to write some consequences of acid rain as well, since it's a 2-mark question. Do not just write acid rain alone. Okay, write about its consequences. Okay, I think no problem. I'm not going to write them out. Part C. You are supposed to write 2 equations. 1 equation for each stage. You cannot write a single equation. Ethan, how do you answer C part 1?
First equation is SO2 plus H2O give you sulfurous acid.
Oh, very good. What's the formula?
H2SO3.
Good. Next.
2H2SO3 plus 2CaCO3. Give you 2CaSO3 plus 2CO2 plus 2H2O.
Okay. So one more time, what do you get on the right?
2CaSO3
Mm-hmm.
plus 2CO2 plus 2H2O.
I mean, obviously you can remove the 2. Okay. Is it balanced? Let me see. Yeah, seems fine to me. Yeah, guys, you share these 2 equations. Sabrina, do you get that? Yeah, so again, guys, be familiar with sulfurous acid. It can come out H2SO3. Yeah, keep this in your mind somewhere. Okay, calculate. Did all of you manage to get the answer? I think both the guys got it. Sabrina, did you? You did. Okay, that's good. Any questions, final questions for today? No? Okay, maybe if there's time, we'll go through some particular next week. All right, so if not, then I shall end the lesson here.